Hello everyone, welcome back to the 11.2 class notes having to do with the matched pairs hypothesis testing for the population mean. In this case, we're going to be talking about, instead of doing the t-test using the differences where we were doing L3 having the differences and then doing the t-test and coming up with the p-value, that's based on the test statistic, all of that stuff, and all of the things that we would read out from that menu. We're going to be talking about the same way that we did before in chapter 10, that it's possible to conduct this hypothesis test using confidence intervals. And of course, we learned a long time ago that confidence intervals and doing the hypothesis testing, they kind of go hand in hand. In this case, though, we have, of course, always this idea of having a confidence level, like 95% level, but that one corresponds, if we wanted to do this as a hypothesis test using the other method, that a 95% confidence level is the same thing as having a level of significance of 0.05, and then everything just works out the exact same way. So it's kind of up to you, or up to your own personal preference, which style of test that you do, whether you're going to use a confidence interval or whether you're going to use the test statistic and this idea of having, the picture with the critical region, all of those nice things that we learned about before. But anyways, we're going to carry on doing this one with the confidence interval. So instead of doing t-test, which of course we're still interested in t because t always corresponds to the mean, and we're still talking about mean, so we definitely want to find something that talks about t. But instead of doing the t-test, we're going to be using a confidence interval, so we want t-interval. I hope it all makes sense so far. Now, there was apparently an experiment conducted online at the University of Mississippi to find out people's reaction times to the stimulus. So probably the screen, see whenever the screen comes up blue, they're supposed to press a key, and then whenever the screen comes up red, they're supposed to press a key. And we're trying to figure out whether somebody, and notice in this case, this data that's matched to itself, this is a particular individual that is being asked to respond to the blue one, and then they're going to be asked to respond to the red one. So this is the same person that's being matched against their self, so that their response time is measured only against their own response time, because apparently, like this person, wow, they react really fast to the blue one. We don't want to compare their blue reaction against somebody else's red reaction. That wouldn't really make sense. So we're trying to find out, for an individual, does it matter whether the screen goes blue or whether the screen goes red, to see who's, what's going to be a faster reaction time. So we will come here, and we're still going to have to do the same thing as far as going into our lists, because we have some data given to us. It didn't tell us necessarily any of the stats as far as what is the mean for this group and so forth, which it would be possible to do it that way. It would work just as well. But let's go in here. I'm going to use list 1 just because of the way these are oriented. List 1 is going to be the blue one, and list 2 is going to be the red one. So you can see it really doesn't matter which one is list 1 and which one is list 2. You just have to pick one, because there's no reason why blue should be number 1, you know what I'm saying? But anyways, 0.267, I'm just going to be putting these data into this list right here, and then we're going to have the same strategy of going into list 1 with the differences. So it will go into here with all of these, and then we will have the 0.512, we will go into here with this other one, and then it will go 0.456, 0.533, and now we have all of the data there. And then we're going to make list 3 the same way that we did before. It's going to be list 1 minus list 2. And then, oops, go to that one. See, I shouldn't have done that. I forgot to go up to list 3 and highlight it and put the formula for list 3 into the actual list 3 box up here. Now it worked out just fine. So we can see this one's a little bit more variable than we saw before with the prices to get the car repaired, where some of these are positive, some of these are negative. So we're starting to maybe draw some of our own conclusions whether there's a difference. But why don't we run this confidence interval? We will come over here. Now we're looking for t interval, which is number 8. And we're going in there with the data for list 3. The confidence level in this case is 0.95. And then let's calculate it. So what's going to happen? Okay, so we come up with this confidence interval, negative 0.092 to 0.288. And so what we see, and of course, this is a confidence interval for the differences. And what we talked about before in chapter 10 is that if the difference is negative, of course, that means that the number from list 2 was more. If the difference is positive, that means that the number from list 1 is more. So if we have this confidence interval that straddles 0, because of course 0 would mean that they are the same if there's a difference of 0 between two numbers, and our confidence interval actually contains 0 in there. It goes from negative 0.092 up until 0.288. So in this case, our confidence interval actually contains the value that there is no difference. And so since it does that, then we have to say, in response to this question, it asks us, is there a significant difference in the response times? And we have to say, no, there's not a significant difference, because it could be, maybe the blue response time is more if we're inside of this region. Maybe the red response time is more if we're inside of this one. And maybe there's no difference because 0 is there. So we would want to, of course, use a complete sentence, but I'm going to say just very briefly, no. Of course, we would want to say something like, we are 95% confident that there is not a significant difference in the response times between the blue and red stimulus. So we would do it that way. And that does it for the confidence interval way of testing these kinds of hypotheses. Of course, we didn't have a hypothesis in this case, but if we wanted to make one, we would set it up like null hypothesis would go that the difference is 0. We are just checking if there is a difference, so we would be doing a two-tailed test checking whether it's not 0. But we failed to reject in this case, and I hope that it's clear. The calculator, of course, did the yeoman's task for this problem anyways, like it has been doing. But we're going to carry on in the next video talking about 11.3, where we will have the independent data, and it will be a bit different. But thank you guys for watching.